Okay, hello. This is going to be your example for how to sketch a graph of a piecewise function. So in front of you, you should have worked examples 2.3, and we're actually going to go over the first two problems together, and then you'll have four more graphs to draw as practice. Okay, so let's look at problem 1. And you have this crazy looking function that says h of x equals, and then normally you're used to seeing an equation that you'd graph. But now you see like 0, comma, x less than -2, -2, comma, x less than or equal to -2. There's a lot of crazy things going on in this equation. So let's take a moment to actually just break down what each part of this equation is telling us before we try to graph it. So, your reading notes this weekend for 2.3 explain to you that piecewise functions mean that there are different pieces or different parts of the function. So we actually have two equations here. One of them is h of x equals 0, and one of them is h of x equals -2. So, like, if I were to write these as two different equations below here, my first equation would be h of x equals 0, my second one would be h of x equals -2. For the sake of ease, this is actually easier for me if I just replace the h of x with a y. It means the same thing. So I'm going to do that to make it easier. So I have two equations, y equals 0 and y equals -2. So I have to figure out how to somehow graph these two equations, and then I'm going to worry about what the second part of this thing is telling me later on. So I highly recommend in today's class using a pencil. I know we don't really use pencils very often, but you will see why when you're doing this type of problem, it's very helpful to be able to erase. So what I'm going to do with my pencil is I'm going to first just graph the first function, y equals 0. Actually, I'm going to start with the second function, y equals -2. So what does this look like as a function? Okay, well, it's a little bit weird. There's no x, there's no y-intercept, there's no slope. Remember, when we have something like y equals -2, it's actually just going to be a horizontal line. It's a horizontal line that's going to go through -2. Whereas a vertical line would be x equals something. Horizontal lines are y equals something. Horizontal line passes through y equals -2. Same thing for y equals 0. It's also going to be a horizontal line, but it's going to pass through y equals 0. Okay, so to graph y equals -2, I am going to go to -2. And then another helpful thing to have throughout this process is going to be a ruler, because you're going to be drawing a lot of lines. And -2, there is there's the graph for y equals -2. Nothing very fancy. Okay, now that I've graphed y equals -2, I'm going to pay attention to the second part of this piecewise function. What does this mean? X is greater than or equal to -2. Okay, so what this is telling me is that this is my equation. This is my line that I've just drew, y equals -2. And the second part is telling me this line only exists, this function is only true on the domain or on the interval x is greater than or equal to -2. So this part, the yellow part, is my function. This pink part, you can think of it as the domain of this function. And we know domain refers to x values, right? So that makes sense. Okay. Whew. Seems like we're connecting a lot of things from Unit 1 and Unit 2 in this one problem. Okay. So we have y equals -2. I know that this function only exists on the domain x values greater than or equal to -2. All right, so here's what I do. I'm going to go to my function. I'm going to look for where is x equal to -2. And what I do to just show myself visually of the domain is I'm going to just shade the area where x is greater than or equal to -2. So here's where x is equal to -2. I'm doing like a dotted line, hopefully you can see. And I know which part of the function is going to exist, the part to the left of the -2 or to the right of the -2. It's actually going to be the part to the right of -2 because x is greater than or equal to -2. So this part of the function exists. The left part, all the part to the left of the -2 I can actually erase, which is why it's helpful to have my eraser. So I'm going to go ahead. This part to the right of -2 is the real function. X value is greater than or equal to -2. This part to the left I can just erase. And I'm going to go over my function in pen now because I know that I have my final piece of the function. Okay, so that is y equals -2 for x values greater than or equal to -2. Next I have y equals 0. That is going to be a straight horizontal line that passes through y equals 0. So it's going to be actually just along the x-axis. And then this part of the function exists for x values less than -2. So again, looking for my -2, this function only exists less than -2. So I'm going to erase the part that's greater than -2. Okay, so I have two pieces to my function. I have the piece that exists for x values less than -2, and the piece that exists for x values greater than or equal to -2. One last thing I have to be aware of is the difference between like a less than sign and a less than and an equals to sign. So what is it going to look like in the graph? That this is less than and this is greater than or equal to. So what that means is at 0, at the value of 0, at the x value of -2, it's an open inequality. So there's going to be an open circle here. Because this function, y equals 0, it doesn't actually exist at -2. It just exists for x values less than -2. So there's an open circle here. Then at my next piece for y equals -2, this is for x values greater than or equal to -2. So this function actually does exist at the point -2, just like on the number line. So it's going to be a closed circle. And that is my final function. Okay, I don't want this video to get too long, so we're going to quickly move on to the next example. My equations look a little bit more interesting in this example. I'm going to go ahead and replace g of x with y. I'm going to graph my first function, which is y equals x. So my first function is y equals x. the slope of this function, I'm just going to make a quick note to myself, the slope of this function is 1. And I'm using the form y equals mx plus b, where m is the slope and b is the y-intercept. So in this function, the slope is going to be 1, and the y-intercept is going to be 0. So I'm going to draw a linear function that goes through the point 0, 0. The y-intercept is 0 and has a slope of 1. I'm going to do this with my pencil because I'm going to end up erasing part of it because it's a piecewise function. So I'm going to go ahead and look something like that. And then I'm going to go over to the next part of my function, which tells me this first function only exists for x values less than or equal to 1. So here the point that I care about is 1. I'm going to draw my dotted line, and then I'm going to think, okay, which side exists? The side less than -1 or the side greater than -1? This is telling me that this function exists for x values less than or equal to 1. So the left part is the real part. The left part is the part that exists. The right part is actually not real. It just goes away. This function only exists for x values for the domain of x being less than or equal to 1. So there is the first part of my function. Because it's less than or equal to, I know I'm going to have a closed circle. And then my next function is y equals, let's do it over here, y equals -2x plus 4. I know I'm going to have a slope of -2 and a y-intercept of +4. So let me go to my graph. My y-intercept is going to be at +4. My slope is -2, which means, like if I think of rise over run, -2 over 1. My rise is -2, my run is 1. So I'm going to go ahead and rise by -2, meaning go down by -2, and run by 1. Down -2 over 1, down -2 over 1. At a certain point, I'm just going to connect the dots and I'll have my line. It's going to look something like that. And then, ooh, that's ugly. Just make that look a little better. And then I'm going to say, okay, this function, -2x plus 4, exists for the x values greater than 1. So I'm going to erase the part to the left. So the function only exists for x values greater than 1. It'll look something like that. And then because it's an open inequality, I'm going to make sure I have an open circle. All right, this is a brand new way of thinking about graphs. You're putting together a lot of stuff from algebra with remembering how to graph linear functions. You're also putting together stuff about domain, and you're putting them all together into these pretty complex graphing problems. So what I would like you to do is complete the next 4 examples on your own. You're going to do problems 3 through 6 on your own. The answer key is included right in here, so you can go back. These are the 2 ones we just did. You can be checking your work. These are frustrating and they take a lot of practice. So we're going to be working on these types of graphs all class, and we're actually going to, all week, and we're going to learn how to do this on technology later this week because these are very frustrating to graph by hand. So good luck, try your best, and know that you're going to have all week to practice this skill. This is just your first chance at it. So try not to get frustrated, just do your best, and you can always come back and rewatch this video if any of it didn't click the first time. All right, good luck. Talk to you soon.